Okay, so let's say we have two equations. We have one equation where x is equal to the price of an apple. Okay, so it's in dollars. Let's say that's in dollars. And x is equal to the price of an apple. Well, let's say we also know we have another equation where x is equal to the price of an onion. Well, if x is equal to the price of an apple and x is equal to the price of an onion, we can use substitution. In fact, since we know x is this and x is this, we can take what x is, which is an apple in this case, and we can put it in for x. So I can substitute in an apple for x, and I can see the price of an apple is equal to the price of an onion. And that's basically how substitution works. Let's say we know some numbers. So say this is a very rare apple and a very rare onion, and this apple comes from the last of a tree that's going to become extinct. So let's say the price of this apple is $50. So x is equal to $50. We can find the price of an onion, saying that x is equal to $50, by taking this $50 and substituting it in for x. If x is equal to $50, I can take that $50 and I can substitute it in for what x was. And so I know the price of an onion is also $50. That's pretty expensive. I'm thinking I might have a banana. So here are our equations, and what we want is the cost to equal the revenue. That's what we want to solve for this. How many books is it going to take for the cost to equal the revenue? Well, we know the answer from graphing, but let's see if we can solve it a different way. So when the cost equals the revenue, we're making no money at all, making $0. And we want to know, what is x when we're making $0 here? How many books are we making when the cost is equal to the revenue? Well, if we look at this, our c of x, we know we want to be equal to our r of x. Well, r of x is $65. So what we can do is we can substitute what that $65 is into c of x, because we want c of x to be equal to r of x. So instead of c of x, we're going to put r of x, but we know r of x is equal to $65. So we're going to substitute that in. So instead of c of x, put that 65x, and that is equal to $25 times x plus $3,000. Now this is great because we have just one variable. We know how to solve this. We want to get all of our variables together. So subtract 25x from both sides, or add a negative 25x. And we have $40 times x is equal to $3,000. Now we want to know what 1x is, not 40 x's, so we're going to divide by $40. Divide by $40 on both sides to maintain equality there. Dollars over dollars is a 1, and I can divide numerator and denominator by 10, and that will give me 300 over 4. I have a 1x, and so I just have x is equal to 300 over 4. I can do that division over here. 4 into 300, 4 into 30 is 70. That's 28 with 2 left over, 75. So x is equal to 75. Now remember, I'm talking about books. My variable x is defined as the number of books. And 75 books is where my cost is equal to my revenue, so I'm not making any money. And I can actually find out the dollar amount I make for both my revenue and how much it costs me by putting 75 in there. And if I put 75 in my r of x, it's going to equal my 75 in c of x, because I did that. That's what I did. I set them equal to. So I only need one of these equations. So r of 75 equals $65 times 75. And when I go ahead and do the multiplication, I have r of 75 is equal to $4,875. I'm not making that amount of money. That's just how much it cost me to produce 75 books and how much revenue I'm receiving. So they're equal to each other, and I'm making $0 at this point. So C of 75, remember, is equal to R of 75 as well. That's the way I calculated it. That's how I used my substitution. And let's go ahead and just compare this to our graphical representation. And right here we have 75 books. And we can go over here and see that it makes about what I got for my Y value. That both my cost and my revenue are equal to about 4,875. Now it's harder to tell on this graph exactly where that is, but using my substitution method, I can double check it with my graphing method. Now we're going to look at another way to figure out when the cost is equal to the revenue. This is called elimination. You know, it's been said that you can actually substitute in an apple for an onion as long as you're not spelling anything. If you're blindfolded and your nose is plugged, the texture is supposed to be the same. So they may be the same price and they may be the same texture. Although I'm pretty sure I wouldn't want an onion for a snack.